Hi there, Year 8s. We are now moving on to Chapter 6, which is to do with ratios and rates. We're looking specifically on exercise 6A, which is just an introduction to ratios. So let's have a look at here. This first part of the example is to get you to understand, well, what is a ratio and how do you write ratios? Ratios is usually comparing between two or more quantities of the same units. Okay, so for each of the examples below, state the ratio of shaded parts to unshaded. So you've got shaded versus unshaded. Okay, so we're looking for shaded versus unshaded, and what's key is the language that they use. They said shaded first to unshaded, right? So that means when you write your ratios, it always has to be shaded by unshaded, shaded by unshaded, shaded by unshaded. Okay, you can't write it the other way around. So the order matters. So in this case, how many pieces are there? There is one that's shaded compared to two unshaded. Even though there are 3 pieces in total, one was shaded and then 2 was unshaded. These 2, when you add them all together, it should give you 3 parts. So that's why 1 plus 2 gives you a total of 3 parts there. Same thing with the next one. Let's see how many shaded versus unshaded. There are 3 shaded to 1, 2, 3, 4, 5, 6, 7, 7 unshaded. So how many pieces in total? There should be 10. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because 3 plus 7 gives you 10. Okay, so that's how we know how many parts to draw up. And we know 3 out of the 10 is going to be shaded, and then 7 out of 10 is not shaded. Same with this one. This is now 5 that is shaded to 4 that is unshaded, and therefore there's 9 pieces in total, because 5 plus 4 is 9, and you can see here it's 1, 2, 3, and this is 1, 2, 3 as well, so 3 by 3 gives you 9 squares there. All right, and that's pretty much what we're practicing. So we're looking at how to write ratios, and then we're looking at, well, how do we know they're equivalent ratios? So here, when you say it's a 1 to 3, okay, so a 1 to 3 would look something like this. So you got 1 that is shaded, and then 3 that's not shaded, right? That's what a 1 to 3 looks like. Well, you could also have, in the same sort of proportion, you could have increased it to 2 that is shaded. But if it's 2 that's shaded, you've doubled the blue. That means you got to double the yellow. Now, if you double the yellow, instead of 3 that is unshaded, it should now be 4, 5, and 6. So there should be 1, 2, 3, 4, 5, and 6, because you're doubling. You're doubling the amount for the yellow. That means you have to double the amount for the blue. Yeah? And that's technically keeping within proportion. And so that's why we do it mathematically. We say, well, the unshaded, 3 to get to 6, I had to times by 2. That means 1, I also have to times by 2. So a 2 to 6 ratio is the same thing as a 1 to 3, but it could also be the same as 10 to 30, 5 to 15, 7 to 21, because all of them, if you compare it to 1 to 3, so here's a 1 to 3, I had to times this by 10, then I times this by 10. If I had a 1 to 3 again, then I had to times this by 5, then I have to times this by 5. And so it keeps it equivalent. Okay, so if this was a 1 to 3, same thing again, I times this by 7, and I times this by 7, and you can see that they are all equivalent. So 7 to 21 is the same thing as 1 to 3. Okay, kind of like fractions. Let's do an example together here. So in this particular example, actually, I'm just going to shrink this one a bit, just so got a bit of space. Let's just move it up a bit. Ratios can be multiplied or divided by a factor to give an equivalent ratio. All right, let's answer this question here. Example 1, in a bag there are 3 green marbles, 7 blue marbles, and 6 red marbles. Okay, so you think about it. A bag has 3 green, 7 blue, 6 red. Okay, that's in a bag. Now, write the ratio of green to blue to red. So it has to be in that order. It has to be green, blue to red. So that means it's 3 to 7 to 6. Okay, write the ratio of green marbles to the total number of marbles. So green to total. Now, clearly the total is equal to 3 plus 7, which is 10, plus 6, which gives you a total of 16. So your answer would be how many greens? 3 to 16. And then same thing for the next one, the ratio of blue marbles to other marbles. So other marbles would then be green or, what's the other one? Red. Okay, so how many blue marbles do we have? We've got 7 of these blues, 2. Well, green and red, if you can have the choice of green and red, that's 3 plus 6, which is a total of 9. Okay, because there's 3 there, and then there's 6 of these reds. So any other marbles would be green or red, so 3 plus 6 gives you a total of 9. Okay, example 2, let's do, now you're going to try to complete the missing box of magic squares using equivalent ratios. So here, same thing. It's a 3 to get to 9. We know that that's times by 3, but then that also means you have to multiply 10 by 3. So the magic box here must be 30. Similarly, over here, you've got 30 to 20, and then something to 4 has to be the same. Well, I can see that from 20 to get to 4, I'd have to divide by 5. That means to get from 30 to this magic square, it also has to be divided by 5, which tells me it is 6. And that should be the end of exercise 6A notes.